So, introduction to Python. On the agenda today, we have what is Python, differences between the program and scripting language, the history of Python, the scope of Python, why do we use Python, installing the Python IDE, and who uses Python today, and what can I do with Python. And we'll also be going through a simple code just to get you ready for Python. So what is Python? Python is a general purpose programming language that is often applied in scripting roles. Python is a programming language as well as a scripting language. Python is also called an interpreted language. Differences between program and scripting language. So a program is executed, for example, the source of the first complied and the result of the compilation is expected. A program generally is a sequence of instructions written so the computer can perform a certain task. However, a script is interpreted. A script is a code written in a scripting language. A scripting language is nothing but a type of programming language in which we can write a code to control another software application. So the history of Python. So Python was invented in the Netherlands in the early 90s by Guido van Rossum. Python was conceived in the late 1980s and is in implementation was started in December 1989. Guido van Rossum is a fan of Monty Python's Flying Circus. This is the famous TV show in Netherlands. So he basically named Python after that guy. Here's the guy. So Python is an experiment in how much freedom programmers need. Too much freedom and nobody can read another's code. Too little and expressiveness is endangered. So a quote from him. Here's another quote on why he created Python. My original motivation for creating Python was the perceived need for a higher level language in the Amobia project. I realized that development of system administration utilities in C was taking too long. Moreover, doing these things in the Broom shell wouldn't work for a variety of reasons, so there was a need for a language that would bridge the gap between a C, which is another programming language, and the shell. So the scope of Python. So Python based on science, so like the bioinformatics, system administration, so Unix, WebLogic, and WebShare, web application development, so the CGI, the JSON scripts, and the testing scripts. So why do people use Python? The following primary factors cited by Python users seem to be these. So Python is an object-oriented programming language. So the structure supports in such concepts as polymorphism, operation overloading, and multiple inheritance. It also, as indentation is one of the greatest features of Python, and it's free. So downloading and installing Python is free and easy to use. It's also powerful, so that dynamic typing. It has built-in types and tools which make life easier. So library utilities, third-party utilities such as numeric, NumPy, and SciPy, and it has an automatic memory management. Also, Python is very portable. So Python runs virtually for every major platform used today. So you can find it everywhere. As long as you have a compatible Python interpreter installed on your computer, Python programs will run in exactly the same manner, irrespective of platform. Python is also mixable. Python can easily be linked to components written in other language. Linking it to fast compiled files is useful to computational intensive programmings. And Python/C integration is quite common to the other programming language C. It's also very easy to use, so no intermediate compile and link steps such as in C and C++. Python programs are compiled automatically to an intermediate form called bytecode, which the interpreter then reads. This gives Python the development speed of an interpreter without the performance loss inherent in purely interpreted languages. And finally, Python is very easy to learn. The structure and syntax are pretty intuitive and easy to grasp. As we said, you can install Python. So Python is a pre-installed on most Unix systems, including Linux and Microsoft OS. But if you want to install it, here's the link to download. You download the latest version of the IDE, install the recent version. Just click on the link to download it. After installing the Python, go to the Start menu and click on Python 2.7, and you can run it. So who uses Python today? Python is being applied in real revenue generating products by real companies. For instance, Google makes extensive use of Python in its web search system and employs Python's creator. Intel, Cisco, Hewlett Packard, CGAT, Qualcomm, IBM all use Python for hardware testing. ESRY uses Python as an end user customization tool, and the YouTube video sharing service is largely written in Python. So as you can see, Python is everywhere in the world. What can you do with Python? Python is a system programming language, graphical user interface programming, internet scripting, component integration, database programming, and you can also use it for gaming, imaging, XML, robot, and etc. So I've also provided a little example code for Python. So it says here we have x equals 34 minus 23, and then y equals a string. So when making strings is in commas hello, and z equals 3.45. And here we have if z equals 3.45 or y equals hello, x is equal to x plus 1, y equal to y plus world, and then just you have to concatenate the string and then print x, print y. Python is enough to understand the code. So indentation matters to code meeting. So block structures indiced by you have to indent. First, assignment to a variable created. So variable types don't need to be declared. So what are if you don't know what variables are just hold values. So like for example, x is equal to 7. So x is holding the value of 7. And then Python figures out the variable type on its own. Assignment is the equal sign and comparison is double equal sign. For numbers plus, minus, multiplication, module as expected. And then logical operators such as and or not are not symbols. And the basic printing command is print if you want to print something. So here's the Python code execution. Python traditional runtime execution model. So it gets the source code, as you can see first, picture. Then it's translated to byte code, which is then run by the Python virtual system. Your code is automatically combined. So if there's an error, it will not run. If there's no errors, it will run. But then it's interpreted. Running Python. So for example, if you just say print hello world or print hello world, and then if you try to print X dot, this is relevant output displayed on the subsequent lines. It will not, then it will not print. If you try to print just a variable, nothing will print because there's nothing in the variable. And then if you want typing its name will then display it. So that 2 plus 3 will equal to 5. So that just is an example of getting started with Python. So module 2, data structures in Python. So here are the 4 main data structures used in Python: lists, dictionaries, tuples, and sets. And we will be learning about them today. First, we'll be learning about what lists are. Lists are the most versatile data type available in Python, written as a list of a comma separated values items between square brackets. So as you can see in the example under list 1 equal sign and then the brackets and then 1, 3, 4, 5. That's a list. Items in the list can be heterogeneous types, so they do not need to be the same type, and lists are mutable. So you can change them or you can't change them. Concatenation produces a new list. So if you want to produce a new list, if you want to add a number, you got to produce a new list. And append adds a new list without changing it. So lists are mutable. A mutable object can be changed. So yes, it can be changed after it's created, but an immutable object cannot be changed. So examples of mutable objects are dictionaries and lists. So examples of a list in its mutable form. So as you can see, we first make a list. I list equals to 9 and 6 of the two numbers. I list is equal to, if you want to make the 0, we are getting the first value 9 is equal to 1. And then we're printing it in, so we change 9 to number 1. List functions. So list to append, as we used before, as an item to the end of the list. So for example, the list on the top, 89,436.7, and then 436,098 and 90. If you want to add 45, 45 will be added to the end. List.extend L, extend the list by appending all items in the given list. So again, for example, in the first list, we have 56, 78, 90.8, and 576. List 3, we have 89, 456.7, 456, and 90, and then we want to append. So you want to add 2 and 3, list 2 and 3 together. So then at the end, we get 2 and 3 together. Same thing, list.insert, we insert an item at a given position. So we see list 1, we have 67, 90, 78, 456. And then we say I list 1 dot insert 3 comma 99. And then we print it. So we want to add 99 to the third number. So 0, 1, 2, 3, and which moves 456 to the fourth. And then if you want to remove an item from the given list, you just say whichever item you want to remove. So we have in the first list, we have 56, 89, 90, 456, and then which we want to remove 89, so 89 will be removed, and you just print it. Here is just some more list functions. So we have pop, remove the item at the given position in the list and return it. So it will remove whichever one, and then it will return it. List.clear will remove all items from the list equivalent to whichever one you want. List.reverse will obviously reverse the list. List.index will return the index of the list of the first item whose value is x. List.count will return the number of times x appears in the list. And list.sort will sort the items in the place of the list. So using lists as stacks. We can also use a list as a stack in Python. A stack follows a property of list in the first out LIFO rule. So to add an item at the top of the stack, you use append, and then to retrieve an item at the top, you have to use pop. So here's an example. So I stack, we first start with 98 and 9. If then we want to add an item, so we want to append, so I stack to append 7. You want to add 7 at the end, and then add 45, and then if you want to pop, it returns the last number, 45. Using lists as queues. Python also uses a list as a queue where the first element added is the first element retrieved. Lists are not efficient when used as a queue. While it appends and pops from the end of the last and fast, doing inserts or pops from the beginning of the list is slow. The upload queue used collections.dequeue, which was designed to have a fast append and pop from both ends. So here's another example. From the collections, we have to import the dequeue. So we first start with 89, 90, 67, 56, and 8. We append 45 and 78, and we pop whichever is left, and then we returns 89. And then Q pop left, it goes back, keeps going, so it starts with 89, then 90. And then we have to add 69 to the end. And then if you print Q, it will return everything. List comprehensions. List comprehensions is very similar to set theory or set builder form. It provides a concise way to create lists. It allows to build a new set from existing sets. It is an extension to the list. So here's an example right here, and we'll be creating a list of two tuples using list comprehension. So first off, we start with iList, which is ABK, comma VHK, and then num we'll be looping through it. So num for element and list for num and L. It will be make it all together. I'll put them together. So dictionaries. A dictionary is defined as an unordered set of key value pairs with the requirement that the keys are unique. So everything can there no be repeats and they have to be unique. A dictionary is a mutable data type. Dictionaries are sometimes found in other languages as associative memories, or associated arrays. Dictionaries are decided by keys, which can be any immutable type or could be a string. So they can be a string, integer, etc., whatever different data type, but they have to be the same. A pair of braces create the empty string, so dictionary dot dot, the curly bracket, not the other bracket. So the brackets have to be curly. So in the example, you can see we made a dictionary, so test1 DC equal to in the curly bracket. And then as you can see, it has the key and the value. So Gonjan is equal to 90, Gupta is equal to 80, and then Parminder is equal to 70. And it'll print each dictionary with the key, which is the name, and then the value, which is the number. You can also nest dictionaries. So as you can see in an example, we have 4 different empty dictionaries, and then the last one we're nesting them together. So test2, and then curly brackets, the key, and then the value, and then we're printing all of them together. Dictionary comprehensions can be used to create dictionaries from arbitrary key and value expressions. So here's this dictionary comprehension. So x colon x to the power of 3 for in x 3 comma 4 9. So that's just multiplying each one by 3. And then there's other different ways you can use dictionaries. So tuples. A tuple is a sequence data type. Tuples are immutable and usually contain a heterogeneous sequence of elements. So we cannot change values of tuples. They are immutable. Simultaneously, assignment is possible in tuples. So you can assign 2 different tuples at the same time, or we can assign a tuple of value to a different name. Tuples they can be nested. As you can see in an example, y equal to 56, comma 8.9. You can see, and then u equal to y. We're using the y, so 56, whatever values y had, comma 2, comma 6, comma 7. So these are nested together. A tuple consists of number of values separated by commas. Just like we use here, 56, comma 89. And we can extract position in tuple using slicing. So if you want to extract a specific position, so number 1 would be extracting 8 because 0 is 56, 1 is 8, and then 9 is 2 in the value. Sets. Sets are an ordered collection with no duplicate elements. Set objects also support mathematical operations such as union, intersection, difference, and symmetric difference. Curly braces or the set function, so set bracket function, can be used to create sets. For example, color is equal to yellow, pink, black, white, pink. The color, and then set will be you have to use the set function, the bracket, pink, white, black, yellow. So to create an empty set, we would use the variable name equal to the set function. You can also convert lists into sets. So like the first one would be color equals set. We're converting that list of yellow, pink, black, white, pink to a set. And then we'll print color, and then which we would get set of whatever it is. set operations. So union of two sets is done by using set, line, and then set. So for example, if you want to union set one, which is 1 6 4 6 8 3 3 9 to set two, which is 7 9 1 5 8 9 3 3, we would get all the numbers with no duplicates. So we would get set 1 3 4 5 6 7 8 9 altogether. An intersection of two sets can be done by using set and then the and symbol, which is on your keyboard, to the other set. So set one and set two would be set 8 1 3 9. It's the union, whatever is in both. And then the difference would be, which is set difference would be what's not included in either. So that would be set 4 and 6, which is not included in either. So 4 is in set one, while 6 is in set one, which is not in both. Strings. String is defined as a sequence or a list of characters. String is immutable in nature, meaning once defined, you cannot change a string. So you'd have to create a different string. str is a type for strings in Python. So if you want to create a string, it will be str. And you define a string using either two brackets, no, two commas or one comma. For example, here st, which is the variable for a string, equal to hello world, which is in brackets. The string is enclosed in double quotes. The string contains a single quote and no double quotes. Otherwise, it is enclosed in single quotes. So here is the string, I am busy right now. I will print I am busy right now. We're just making sure there are quotes on both. So for example, in the second I am busy right now, there are two quotes at the beginning, but none at the end. There will be a syntax error. Dash n is used to place a string in a new line. So if you use the dash n sign, whatever is after that we'll place it in a new line. So as you can see, we automata dot the line, no object oriented programming will be in a new line. If you don't want characters prefaced by the line to be interpreted as special characters, you can use raw strings by adding n or r before the first quote. Here's an example. Two or more string literals next to each other are automatically concatenated, and attempting to use an index that is too large will result in an error for strings. Accessing strings. To access substrings, use the square brackets for slicing along with the index or indices to obtain your substring. For example, we have st, which is the string, is equal to hello Python. We want to get st number one. So as you can see, h is in the 0, and then st will be equal to e, which is the second index. If you want to get the last one, we would have st in brackets -1, which is the last index. Here's this positive and negative indices. So as you can see, we always start with, in Python, we start with 0, 1, 2, 3, 4, 5. And then to go reverse, it will be the opposite. So -5, -4, -3, -2, 1. Operations on strings. So concatenation, or in brackets plus, we add a value on the either side of operations. So here we have vast, which is equal to hello. We have a new variable t, which is equal to vast plus there, and then we will add them together, hello there. Repetition. Creates a new string concatenating multiple copies of the same string. So here we have t is equal to, in commas, I am underscore busy. And then we have y, which is a new variable, t times 2, which is going to repeat I am busy twice. And we print y, y will be equal to I am busy, and then I am busy, so twice. Slicing, which we already did, was giving the character, which we did in the last slide. So if you want to slice the T2, we would get A, since the underscore is index itself. If you want to range a slice, you can also do that with the brackets and then the square brackets. So in this example, T is equal to I am busy. We want to slice from 2 to 4. So I is in the 0, underscore in the 1, A is in the 2, M is in the 3, underscore is in the 4. So since it will be, then we would have space, A, M, and then space from 2 to 4. Here are some other operations you can do on the strings. So membership in or not in. The membership returns true or false if the character is in it. So T is equal to us, and then we want to print U is it in T? Yes, it's true. And then here's another example. We have a variable T equal to Mohan. We want to print is 1 in T, and it's going to return false, obviously. We can also find the length of a string by using the len operator. So here we have T is equal to Mohan again. Find the length of a string. We count every single character. So we don't start from 0, we count every single character. So 1, 2, 3, 4, 5. So the length of this string will be 5. Another operator is the upper, if you want to uppercase the whole string. So we have a string over here, variable A equal to divavshish. It will make the string upper. And then the opposite, of course, lower. It will make everything lowercase. Here, modifying strings. You cannot update a string in place as strings are immutable in nature. So for example, here, we have a string called hello world. If you want to change the third index to P, you cannot do that. We will have to create another string or use slicing and concatenation. So here's how it will work. S is equal to hello. We create another string S is equal to S and then the range and then plus P, which will change it. And then print S, we'll have help exclamation point. Here's another example of slicing in strings. So as we learned for this example, so start and end, where you want to start from and then where you want to end. And then string formatting. str.format is used to format a string. So replace an argument by position in the message string. So for example, first and second, if you want to format 34 or 32, the first will change to 12 and then the second will be 34. So that's all for Python data structures. So introduction to pandas and NumPy. NumPy. So what is a NumPy in Python? NumPy is a fundamental package for scientific computing in Python. It is a Python library that provides a multi-dimensional array object, various derived objects, and an assortment of routines for fast operations on arrays, including mathematical, logical, shape manipulation, sorting, selecting I-O, discrete Fourier transformations, and basic linear algebra, basic statistical operation, and random simulation, and much more. Application of NumPy. So here are some of the applications of NumPy: mathematics, plotting, back end, so like Pandas, Connect for digital photography, OpenCV, and machine learning. So here are the basics of NumPy. So in order to create a NumPy array, we would name the NumPy MP and then dot array brackets. And dot dim returns the dimension of the NumPy array. The shape returns a shape. The D type returns the data type of the NumPy. And the item size returns the size of the NumPy. So here's the concept of slicing in NumPy. So array and then brackets row, comma, colon. It's for the specific rows in all columns. And then the opposite would be array, colon, and then comma column for the specific columns and all rows. And then for both, we would have array in brackets row, comma, column. Installing NumPy arrays. So np.zeros creates an array / matrix containing all zeros elements. np.ones creates an array - matrix containing all ones element. np.full creates an array - matrix with all elements at a specified value. np.random creates a random, all decimals randomly. np.random.radian creates any array matrix containing all elements, integers, values randomly. np.identity creates an array / a matrix whose all elements are 0 and primary diagonal. Be careful before making copies of variables. Additional, so it's basic mathematics, so like sin and cosine. It's linear algebra, so matmul, linear lag, det, and statistics, so like maximum, minimum, the sum of it. Reorganizing arrays, so like you reshape it, so change the shape of the array or the matrix. A V stack and a H stack. We load data in form of file. So the gen from txt, which data will be generated from or by the help of a text file. And extra, so like a type changes the data type of the data. So pandas. A picture of a panda. What are pandas? Pandas is a Python library used for working with data sets. It has functions for analyzing, cleaning, exploring, and manipulating data. What is a data frame? A pandas data frame is a two-dimensional data structure. It's basically like a two-dimensional array, which is a matrix, or a table with rows and columns. So here's an example of a data frame. That extracts data from a data frame, which is very similar to the NumPy. We use df for data frame, .head, .tail, .columns, .index, .size, .shape, .type, and .describe. So the values to get a value at a specific cell, we see data frame .at whichever row index and then the column name, or df at row underscore index, comma column index. If you want to fetch a record, df.lock rows. Rows can be an integer or non-integer value, and then df.ilock. Rows must be an integer value. If you want to find, remove, or impute null, we use isNut, fillNut, or dropNut. Here are the properties, so like maximum, minimum, mean, unique, non-unique, and values are counts. Here are some of the set operations using the concat method. So pd.concat will be data frame 1 / data frame 2, and then pd.concat, same thing, but if you want for duplicate it, and then df.append, which if you want to add something at the end. Saving your data frame, you use to_CSV, to Excel, to_JSON, to_HDF, or to_SQL. Here's a summary of everything that we learn in Pandas and NumPy. Here in the next module, we will be learning about CSV files. So what is a CSV file? CSV files are used to store large numbers of variables or data. Incredibly simplified spreadsheets, so you can think about Excels, only the content is stored in plain text. The CSV module is a built-in function that allows Python to parse these types of files. The text inside a CSV file is laid out in rows, and each of those has columns all separated by commas. Every line in the file is a row in the spreadsheet, while the commas are used to define and separate cells. So the CSV module. The CSV module is useful for working with data exported from spreadsheets, such as Excel, and databases into text files formatted with fields and records and commonly referred to as comma-separated values. So that's what it stands for. If you want to import or export spreadsheets and databases for use in the Python interpreter, you must rely on CSV module or comma separated values format. So here are the steps of using CSV. First, save the Excel file with the .csv. So when you're saving your Excel file, save it as CSV. Second, save the CSV file in the same folder where the Python file is there, and then write the code for reading and writing your CSV file. Here, just reading a CSV file. There are two ways. You can use the CSV modules reader, or you can use the dict reader class. So you're going to read it, so import, and then if you want .csv.dict reader, it will read the CSV file for you. You can also use a reader class, import with open, and then .csv as a CSV file. It will read your whole file and output this. Writing a CSV file. The CSV module also has two methods that you can use to write a CSV file. You can use the writer function or the dict writer class. So here we'll be using the dict writer class. In this example, we'll be writing field names, so the first underscore name and the last name of the people that we'll be using examples. Next, we'll be looping through rows. So press open, and then for row and the CSV, we print row for the first loop. In this, we create an empty list. After creating the empty list, we have to add the row to the list and print the list after we loop through it. Converting a list to sets in a CSV file. First, we import the CSV module while manipulating with the CSV file. Here in the code, set function is used to remove any duplicates. So remove any duplicates in sets. We're not allowed to have any duplicates. And then print the value once only. Pandas is an open source Python library for data analysis. Panda introduces two new data structures in Python, series and data frames, as we learned before. Here we'll be learning about series since we already talked about data frames. A series is a one-dimensional labeled array capable of holding any data type. It will assign a labeled index to each item in the series by default. Each item will receive an index labeled from 0 to n, where n is the length of the series minus 1. So here we'll be creating a series with an arbitrary list. So here we have three names, Monica, Lala, and Purva. We will be adding the series to the name. So Monica gets 0, Layla 1, Purva 1, 2. You can arrange the values in a list of the series from using the pd.series data structure. The D type in output is object, as the strings is taken into the object data type. Alternatively, specific and index to use when creating the series. Here you can see the names in order from Monica, Lalit to Purva. The pd.series will have the names.index. So student 1 will be Monica, student 2 will be Lalit, and student 3 will be Purva. The series constructor can convert a dictionary as well, using the keys of the dictionary as an index. The constructor converts a dictionary key to use it as an index. Here's another example of a series. So curing a series. We can basically query in series using the lock method, which is used when we query about a label, and the iLock method is used when I query the data using a numeric value. Here are some examples. And the data frames that we learned about in the last Pandas and NumPy. And next we have a group by. A group by is a function used anytime when you want to analyze Panda series by some category. So whatever a specific category you want to analyze. Here's a group by example. In this code, if you want to find out the main British 2012 column, worst city name, add a country, then it uses this way. You only want to find the add a country, add a county. Here's another example. In this line of code, if you want to calculate the mean over across all the columns for each city name, then use this one. The AGG function. This function allows you to allow the specific multiple aggregation functions at once. So in this code, the function is used to aggregate the value for count, minimum, maximum, and mean all at the same time. This function you can use it for a lot of things. Scales. So a ratio scale, units are equally spaced, mathematical operations are all valid. Example, height and weight. That's for a ratio scale. Interval scales are equally spaced, but there's no true zero. Ordinal scale, the order of operations is important. So the letter grades such as A plus and A are good. And nominal scale, categories of data, but the categories have no order with respect to one another. Here's a nominal scale example. The asType function simply converts the data type of one form to another. So it's converting to grades to excellent, good, and okay. Ordinal, there's another example. If you want to arrange the resulting data in ordered form, then ordered attribute is used. So we want to order the grades from best to A plus all the way to C plus. So A plus obviously the best, and then C plus is the worst. Here's some more examples. Moving on to pivot tables. To give a better representation where the columns are the unique variables and the index of data identifies individual observation. To reshape the data into its form, we use a pivot table. It's an example of a pivot table. Here we can use the ag function and pass to a number of aggregate operations you want to apply on. This is another example. Data functionality of pandas. In this, the ABC is the index assigned to the timestamp value. Here we're converting to date and time with the date time function. And the time deletes it deletes the difference in time between the two timestamps. Merging data frames. So here we use a CGM to merge the data frames together. We also use the merge function to merge the two data frames. So staff data frame and the student data frame. Inner join is another function. Left join is if you want to make it to the left. And then right join is obviously if you want to join it from the right.